you all signing on today. We kind of took the summer off. If you've joined us before on our asset management webinar series, we've been doing these once a month, and then we took a few months off in the summer. So we're certainly glad to be back up and running and excited about today's webinar looking at Spectra Geospatial and one of their software products in particular. My name is York Groh. I manage our mapping and GIS product line here at Duncan-Parnell, and certainly welcome you all and glad you're here with us today. This session will be recorded so that at the end, usually towards the end of the week or on Tuesday, you'll be receiving an email back from us with a link to a recording that you're welcome to pass on to other folks. And also those that signed up today that were not able to join will also get this same information and link to the recording. We welcome your questions throughout the session, and feel free to use the chat window. We've got everybody muted for the duration of the seminar itself. Towards the end, we will turn or let you unmute yourself if you'd like to ask a question verbally, but feel free to use the chat session as we go along. There's a couple of gentlemen that are joining us today as presenters, and they'll be answering those questions as we go along. So with no further ado, we're ready to get started. As a way of introductions, Marissa Body is with us from Duncan-Parnell. She's our marketing coordinator. She's the one that makes this all happen, so certainly appreciate her efforts. Our special guests today are Joe Binder and Joe Sass. I'll let Joe will probably give us a little bit more introduction of themselves, but I'll let them take it away. Gentlemen, go ahead.
Thank you, York. This is Joe Binder speaking, and I handle the Spectra Precision Geospatial side of the business for Trimble. For those of you unaware, Spectra is a division of Trimble, so we have deep roots in GNSS, and Spectra on itself has a number of deep roots as well. So we're going to speak today particularly about the MobileMapper field software, which resides on an Android-based platform. You've got a number of different options. With regard to some of those, we have actually been in the industry for quite some time, and we happen to have, I can get this to forward, there we go. We happen to have about 28 years of experience in this business. So the program has been refined, it's been simplified, and it's a pretty strong program. The actual hardware itself, you know, we've grown quite a bit with that as well. And you'll see towards the latter end of this slide, we have a number of devices that are Android platform that are available today. While we're going to be talking about MobileMapper Field, some of the things that I'd like to highlight about MobileMapper Field and the hardware is some of the varieties of accuracy and capabilities that you get dependent upon the hardware choice that you make. So available from us directly, we do happen to have what we call the Ranger 5, SP20, and MobileMapper 60, which are going to be a platform with a display that the MobileMapper field will go on. And they can interact with our GNSS receivers and actually allow you to get centimeter grade accuracy in the field. So the software, of course, that we're speaking of is MobileMapper Field. There's an Office component that is available for that. And then there's a third component that is called SPACE, which is Spectra Accuracy Enabler. What that program does, in essence, is will allow the hardware device that you're utilizing to direct the GNSS incoming data, whether that be the internal antenna of the device, such as a MobileMapper 60, or whether that's an offboard high survey grade accuracy type centimeter level unit that you want to use and get greater accuracy out of the hardware. And then it will direct that data to the application, MobileMapper Field in this case, or a number of third-party applications that are available for Android. So that's sort of the intermediate software program available. So the SP20, being one of these devices, consists of a handheld with a GNSS receiver built into it, utilizes a number of the features that you'll see on most hardware today, camera, long-lasting battery, built for the field, Gorilla Glass, etc. But this unit is available in a number of different accuracy configurations. So it's scalable from an autonomous position of a meter or so with your SBAS corrections all the way to a centimeter real-time with either a VRS or what we call RTX. So RTX is a satellite that we have that provides that correction via the internet or via the L-band antenna that is internal to the SP60 and the SP20, where you can then get about 2 centimeters anywhere within the RTX coverage, which is pretty much all of North America. So different hardware field configurations, whether it be a handheld or a couple of different pole options, or if you're going to go with the external antenna. And one of the unique features, again, that MobileMapper Field has is going to be dependent upon the hardware. And one of the unique features with this MobileMapper 20 is the idea of utilizing a camera to get directly over the point and plumb as opposed to a rod. And we've got a little presentation here that will go through that concept. So as you start to collect your point, tell it you want to see the rod, and we've got the rod there in addition so that you can see the how it comes into play. You're noticing the circles moving as you are plumb over the point, etc. So MobileMapper Field has a number of capabilities that are going to be hardware dependent in some cases, as this example is here. So that space program that we talked about, that middleware, this is going to allow you to get to some of that higher accuracy utilizing the SP85 or SP60 that we have, or the SP20, which we just showed you. And again, this will work with most of the Android apps that are out on the Google Play Store for you. So with that, I am now going to turn over the MobileMapper Field software presentation to Joe Sass. Joe is our technical sales, and he knows this program inside and out. And so with that, Joe, are you available?
I am here. I am here. Yes, I'm available today. I slotted out a few minutes of my time for you guys.
Oh, thank you. Thank you.
So MobileMapper Field has been around a long time, as Joe Binder said, 20-some years. And it's had several iterations. Originally, it was a Linux-based, Unix-based platform. Then we went into the Windows CE world, and now we are in the Android world. So MobileMapper Field is an Android-based software. And if I had one sentence to describe it, I would say easy to use. Next. Joe, next. Mr. Binder.
I hear you. Yep, I'm trying to get her to move here. There we go.
Nope, you went one too far.
It jumped a few there.
So, thank you, right there. The takeaway here is the easy to use part. This program is not polluted or complicated with a lot of extra buttons. If you have internet, the map just automatically shows up. It's a Google-based map. And you can see here I've got a number of waypoints that are loaded. The status up at the top with my HRMS values, my VRMS values, the fact that I'm in a fixed solution, 2 seconds since I got my last correction, tracking 14 satellites. So it's all pretty much right there in this image here. I've clicked on one of those waypoints. It gives me its name. It gives me its northing and easting and hiding. So again, very simple to use program. And it's available to work within the real-time network. So you can be getting centimeter type corrections in a survey type environment, or you can just do it mapping grade with the internal antenna of the MobileMapper 60, for instance. Or you can actually collect raw data, and we'll talk about that a little bit later. Raw data is for post-processing purposes, which means I don't have to have a live correction source at the moment that I'm collecting the data, and we'll get into that a little bit later. The program is based on shapefiles. So shapefile in, shapefile out. There are some other options such as DXF and CSV, but they're kind of narrowcast in their use. And I find that the shapefile seems to be the common format that everybody can manage and deal with. Next. Some of the features from the buttons at the bottom is a go-to command. If I hit that little teardrop down there, Joe Binder, yeah. So
I'm getting some delay. I apologize.
I'm clicking on one of the waypoints, and it's telling me the direction and the distance. So again, a very simple interface on the go-to command. Next. Here you can see I've got what, 1, 2, 3, 4, 5, 6, 9, at least 9 different shapefiles loaded into the program. These came from the California Archaeological Society, so they're an open platform. The software will accept virtually any shapefiles. I saw that York asked a question: does it have to be limited to the MobileMapper, to the Spectra hardware? The answer I would like to give you is yes, but the real answer is no. It will work on just about any updated, modernized Android operating system. Understand, though, for instance, that there are some Android platforms like Nexus that do not have internal GPS. And so if you were to load that program on there, you'd have to use an external GNSS source to get your positioning. Next. Here, just logging a point feature, so I can create point features in the field. I can load existing shapefiles from a database, and I can additionally, I can edit my shapefile in the field. That could be a double-edged sword, good, bad. We had enough requests over the years to be able to do in the field editing of the shapefiles, maybe add a feature or change a feature or add an attribute, that we now allow you to do that. And in the creation of a point feature, for instance, or a line or an area feature, as it were, we have predefined attributes so that you don't have to go through and define each and every one yourself if you want to use just typical canned attributes, or you have the ability to create your own attributes. And those features can be attributed by menu, by choice list, by mandatory. They can be pictures, etc. Next. So within the log point or log line or log polygon feature, we also, by hitting those 3 dots that you see there, we bring up additional settings so that I can set my antenna height, for instance. I can set how long I want to occupy a point, if I want to use a rangefinder, or if I want to do an offset. So we have additional settings there, but again, notice how simple and uncomplicated this page is. So next. Apologize, guys. I think I'm about to get some noise. I've had some unexpected visitors here today, so hopefully it won't interrupt us too bad. Here I'm logging a point. Looks like I was supposed to be on point for maybe 30 seconds. I've got the different attributes there that I can populate or can automatically be populated. And you can see right now I've got a fixed solution and I'm averaging the points in a real-time setting. Next. Here you can see the floppy disk at the bottom. I can save it if everything looks good and all of my attribution has been done correctly and the point has been collected to my satisfaction. I can hit that floppy disk there, and I'm sorry, guys. I can hit the floppy disk if I happen to have a Google account and the Google account is tied into my data collector, then it will automatically save to my Google Drive as well. So both locally and on the cloud. Next. And as York said earlier, this is not a lecture, this is a discussion. I welcome questions either now or later. Sometimes if you ask them in the moment, they have more context relativity. So here you can see the main menu. And I think probably from here we'll go into the settings, but you can see you've got your import and export dialogues, layers and features. You can open existing jobs, you can create new jobs. The version of the software is under the About menu. And I think we should probably go in and look at settings next. Some of these are rather easy to understand. linear units, feet or meters, obviously, that type of thing. GPX down there at the bottom, Record GPX, is an open format. It might have been developed by Garmin, and it shows just like a track record of where you've been. You can turn that on. And in order to turn on the raw data, record raw data for post-processing, you would need to have a license. If I try to click on that button right now, it's going to pop up another box and ask me for my license number. Next. And here I have clicked on the raw data, and you can see here that it's asking me for my POPN, which is a Trimble issued number that goes into our Oracle database. And the Oracle database is looked up, so you would need an internet connection at this point. And once it's authorized, then you've got it licensed on your device in perpetuity. Next. Here, as I mentioned, there are some other export and import formats like CSV and DXF and MIF files as well. But really, the program is designed to work well and to work intimately with both 2D and 3D shape files. Next. So, yeah, so there is this idea that most GIS software programs, field software programs, have this idea of being able to nest. So I can collect a point. There is no nesting there, but I could be collecting a line, for instance, or a polygon. I could pause that line or polygon and collect a point. I can log a polygon and pause that to collect a line. So, and in that polygon and line feature world, I can either collect epoch by epoch by epoch by epoch, or I can collect several epochs on a vertex and then pause it, go to my next vertex and resume and collect more. So you have a variety of ways and accuracy levels that you can predetermine through the settings and then actuate through the way you actually conduct your survey. Also note that a lot of the GIS products out there in the market do not support geoids. We do support geoids. I give you a resource there where you can download the latest geoid models for your geography. Next. So here is a little video. Joe Binder talked about using space to take your accuracy, say from SBAS, which is 1 to 2 meters. Here you can see it says DGPS, which means it's probably getting WASP corrections. And the accuracy, as you can see, is in the 3 to 7 meter range here. I go into space, and it will connect to my external receiver. You might have seen that icon illuminate up there. And now I've got all kinds of satellites in the sky. And this is coming in through my SP60 GNSS external receiver, which is a survey grade. And you can see the different settings I have here. We won't go into those here. There is quite a bit of functionality here. But if I click on the N-trip, I can click on the arrow and take me to the next button. You can see the different varieties of correction you can get. Here I'm scanning to see what receivers I want to connect to. Maybe it's not the SP60. The SP60 happened to be the last receiver I connected to. Failed to respond. That's not typical, and I probably should have re-recorded that. But here you can see my correction information. I'm connected to a mount point on my N-trip caster called JNS_R, and you can see here that I've achieved a fixed solution. So leaving space open and now going back to MobileMapper field, you see that I went from DGPS to fixed. So space is actually passing through those corrections after negotiating the N-trip connection or the RTX correction, and leaves me here in a fixed solution so that I can do my work at a survey grade. Next. So here I'll just walk through very quickly how to create a new job and look at those settings. You can begin the video. Click on those three dots at the bottom. I can either create a new job, so I will, or I could create an open job. These are jobs that have a .map extension, and you'll see that later on in the presentation. So I'm creating a job called Demo 2021, and it will be .map. I can use my previous job settings. If my work is the same day after day, and I can just use the same settings day after day. If not, I can go in and create my own settings. And these are just the choices that you have there. So again, these are Google Maps, so you can get any of these that Google has to offer in your area. We also have the ability to use web map services, WMS, and we can import background maps and rectify background maps. It's not optimized routine in my opinion, but it can and does work. So here you can see that I'm in the United States, at 83, California Zone 6, and I'm using the latest G8 18. So that's job and settings. Turning on my GPX, and I can also turn on or off my raw data. Raw data should be long continuous files. So if I'm going to be collecting raw data, at most I want 2 files for the day. I want 1 file in the morning before lunch and 1 file after lunch. Right? So long continuous files, don't turn on and off raw data. You'll just really hurt yourself in that way. Next. We want to create point, line, and polygon. So again, we have the ability to create features and attributes on the device itself. Hit the layer, import layers, so I can import layers, but I can hit that bottom button there and then the plus sign, and I can create my own layers. We have 3 different types of layers that we can create, point, line, and polygon. I'm creating a point feature here. And here we can either define our attributes or use predefined or any combination of both. So here you can see the predefined attributes of a point shapefile. If I want to add my own user defined, I can go in there and create that as well. Give it a name and then choose what type of attribute it is. Is it going to just be any text? Is it going to be a menu? Is it going to be a choice? Is it going to be numeric? Is it going to be a date? So here you see all of your options. If I make a menu, then I'm allowed to create my own menu choices. So this one, I might just have good as one menu choice and bad as another, or poor, or fail, or fair, as it were. And so now when I go to collect this feature, I will have not only the predefined, but also the user-defined attributes of the point. So here I'm going to create a line feature. And again, line features, typically you want length. So those are going to be available under the predefined, or you can create your own. And ditto for the most part with polygons. So we've got a point feature, we've got a line feature, we can show them or hide them. So we can have 20 shape files loaded in our job, but we can show only 1 or 2 of them if that removes some of the clutter for us. I believe, maybe I'm tainted by all of my experience, but I believe this program is dead easy to use. I have really only done training a couple of times on it because it really, between the documentation and the intuitive workflow, it's pretty simple to use. So you can create, I see that York asked a question about where can the shapefiles be created. I can use the Office component that we talked about earlier and that we'll talk about later to create shapefiles in exactly the same way that you saw me do it on the data collector here. Or as I mentioned earlier, it's fully compliant with the worldwide shapefile standard, so I can import shapefiles from anywhere I want. With the caveat, make sure you have coordinate system parity among all of your shapefiles. So I think in this one, I give you a brief demonstration of the pause and resume, nesting, and raw data. So just the actual working with the software in real life. Well, it's not. It was real life, but it's not a real job, right? So first thing I do is turn on the raw data, right? Now I'm going to go out and collect a point. Hit the red button, and that begins it. Right, I've got a 10-second occupation that I set up under the job settings, or the occupation settings, excuse me. The ID, I've given it point ID 1, and I hit the floppy disk and the data is stored. So now I want to collect a line, right? But I also, I think, want to collect a polygon. So I might start the line and pause the line. And you can see the pause button down there. And if I hit that pause button, I would then be given the opportunity to collect a polygon. I guess I'm not doing that here. but I could do that, and you can see my icon moving as I'm creating the line feature. And I can either hit the pause to nest a point or a polygon, or I can hit the stop button. I've hit the stop button, I give it a name, it tells me the time and the length, and I can simply hit the save. Zoom in, zoom out, fix on center. I'll collect another point on this vertice, and it's going to be a 10-second occupation, fully user definable. My experience is that I want at least 5 epochs minimum on any point feature that I collect. If it's worthwhile, I'm there. Might as well make sure I've got it well. You can see again that I'm in a fixed solution. I'm going to collect another line. And I think you guys get the idea here. We don't need to belabor this video. But Joe Binder, maybe you can jump to the end of this. Give me the last 10 seconds or something. No, of that video. I guess we are almost there. So here, yeah, just leave it there. Here you can see I've collected 4 points, 4 lines, and 1 polygon. And if I want to change the colors of these icons or the polygons or the lines, I also have that type of control under the settings, under the layer settings. Next. So I guess what I didn't show was after I'm done with the data collection, I then go back in and I turn off the raw data, because I may want to bring it into the Office software for post-processing. Right, so let's take a look at the Office software. First off, MobileMapper Office is free. You can go to my website right now, you can download it, and you can use it. It's a great data management and visualization tool. So I can take any, this happens to be a shapefile from my city of Moreno Valley. Right, I asked them for the shapefile for the streets in my neighborhood or the lots in my neighborhood, and this is what they gave me. And I didn't pay anything for those shapefiles, nor did I pay anything for the software. You can use it to prepare job templates. You can use it to create shapefiles. The only thing you need to pay for if you want to pay for something is to do the centimeter post-processing. Now, notice that I say upgrade to centimeter post-processing. You can actually do L1 code only post-processing into the software for free. So if you have the raw data option turned on in the field software, where it allows you to collect that raw data, let's say on a MobileMapper 60 or an SP20, you could then bring it into MobileMapper Office absolutely free and take that 2 to 3 meter data and process it down to 0.5 meter. If you want the full survey grade, that is a paid upgrade. That would require a POPN number, like I mentioned earlier, for the field software. Also, if I don't have my own base station, the software has an automatic internet search option where it can download base stations from a certain distance away or a number of base stations that are closest. Next. So here you can see that the software is already installed with the post-processing sub-meter level accuracy. That's what I was talking about earlier. L1 code-only post-processing is included with the free version of the software. However, if you want to unlock the centimeter post-processing, you will have to go into the license manager. I show you what that button looks like up on the toolbar, and it will open up this dialog box where you will then hit the upgrade button and insert this four sets of numbers and letters there, like you see there. Next. So I did 3 jobs that were identical: 4 points, 4 lines, 1 polygon. In all 3 jobs, same dimensions on all of them. But I wanted to show you what different hardware does to those file sets. You can see that I've got different number of files depending upon how I've got it configured. The first one, I'm using a MobileMapper 60 data collector with an SP60, and I'm doing it for post-processing, juxtaposed against the last column where I'm only doing it for RTK. And then in the middle there, I'm not using an SP60 at all. I'm not using any external GNSS. I'm using the internal GNSS of the MobileMapper 60, and I'm doing it in a post-processing scenario. So let's take a look at what's in common and what's different next. So this is what's in common, the shapefiles, right? The shapefile is a shapefile is a shapefile. And whether I'm doing it in real time or post-process does not affect anything. It's the shapefile, right? And for those of you that are in the GIS world, you probably understand these file extensions, DBF, DRW, PRJ, SHP, SHX, better than I do. I have a rudimentary understanding of what they do and what they mean, but these are shapefiles. Next. So here I talked about when we create a new job, it basically takes the job name, slaps the .map at the end, and that's what you have both in the office and the field is this .map, which I would liken to a walnut shell, right? It's the shell that goes around all of my data. It doesn't really do anything, but it's there with a name to call, you know, to wrap all of my data around. Next. So here, where we've got post-processing involved, depending upon if we're coming out of the MobileMapper 60 directly or we're using the data on the MobileMapper 60, we have different files. So we see this CRW file, .crw, .urw. Those are files that are coming from uBlocks. So uBlocks is the type of GPS chip that's inside the MobileMapper 60. My engineers understand that format well. In fact, we understand it almost better than uBlocks in a post-processing environment. And that's what you get there. But notice that on the MobileMapper 60 with the SP60, you have these additional files that have a .133. In fact, they have a 20.113. The 20 means that this data set was collected in the year 2020, and the 133 means that it was collected on the 133rd day of the year. Okay, so that's kind of the syntax of these files, and these are the high accuracy raw data files coming from the SP60. And that covers that. So let's take, is this a video? No, I don't think so. It's not. So we'll just talk through the typical workflow. So the first thing we're going to do is we're going to open up the .map file that we got from the data collector. The data collector is where we did all the work. It's got this .map file. So by opening up the .map file, it brings along all of the other data that we did in the field. Next. Kind of has tentacles attached to those other files. So once we bring in that data, it's displayed. There's been no correction applied to this data. If it was collected in real time, there's no need to correct the data. But if this was collected with the idea that we're going to post-process the data, this is the way it looks. It's just uncorrected raw data, 4 points, 4 lines, 1 polygon, and it looks like maybe a base station out there, right, off to the lower left. Next. So I add the raw data. Those are that .133 files that we saw in the previous slide. This is where we're going to import that. We're going to add the rover raw data and watch what happens on the next slide. We now see that we have 2 different rover files, right? Those are those blue lines. So for whatever reason, the data collection scenario was split, breaking my own rule, which I told you just a few minutes ago, of long continuous files. But as I would say as a teacher, these are strictly for didactic purposes. Next. So we need reference data. We need some kind of correction data, CORS data, our own local base station, maybe a local reference station from another survey firm, something like this. So we'll import reference data and see what happens on the bottom there. Next. So here you can see my reference data is that yellow line. And I could have gotten it a variety of ways. I might have had that file on my computer already. I might have used the internet search tool to go out and find it. I might have had a local base station of my own that I just downloaded it from. So there's a variety of places that this reference data can come from. But notice up in the upper right-hand corner of the map display, you've got northing, easting, and hiding there, right? And this is your control. This is your reference station. This is what's going to determine the datum for your rover data. This is important to know. So my reference station, I took that raw data and sent it off to OPUS, the online positioning user service. That's a service of the National Geodetic Survey. I sent them my raw data file in Rhinex format, and they sent me back this email with the precise northing and easting and hiding of my base station. So I plugged these values into MobileMapper Office so that I can control the data. Next. And then I hit the process button. So start processing. And if you look at the top of the MobileMapper Office software, that ribbon is basically a left to right ribbon. You start by opening a job, add layers, add rover, add reference, process. It's that simple. It just, there's not a lot of hidden features in the software. It's pretty much on the surface, and it pretty much is limited to what it does, but what it does very well. Next. Nope, yep, there you go. So, right there. So it's important to understand post-processing of shapefiles. You're not really, the feature and the attribute are the feature and the attribute. They don't really get post-processed. What gets post-processed is position. And so what our engineers have done is they have defined the accuracy of these features by a new shapefile layer called vectors. And so in this way, we can assign epoch by epoch an accuracy level instead of just trying, for instance, how would you determine the accuracy level of a line? Is it the whole line, or is it the epoch by epoch? And our engineers decided it's epoch by epoch. And so what you can see here is, for instance, you see all those green lines on the bottom left-hand side of this image. I walked from one corner to the other, and I had it logging the whole time. So what you see there are you see a series of vectors, epoch by epoch vectors, as I walk that line. But if you look at the top set of vectors, there's only a single vector, it looks like, going up to that corner. Well, what I really did was just collected like 10 epochs on the point and then hit pause, right? So there's a variety of different ways. If I had just done epoch by epoch and no averaging on the vertices, then I would have had green lines, green vector lines, or red vector lines if the vector failed surrounding it. And this is how I determine my accuracy. So if I wanted to, for instance, see the accuracy of one of these corners, right? So one of these corners, do I want to click on a single vector like you see in the middle? That gives me the accuracy of that vector. Really what I want to do is I want to look at the average of the vectors on that vertice, and that will then give me an idea about the accuracy. And here you can see in a very up close, both the post-processing solution on the far left and the real-time solution on the far right have very similar levels of accuracy, because RTK and post-processing are virtually the same. We're just using the engine in a different place, right? The RTK engine is being used inside MobileMapper Office for post-processing. So you can see that there is nowhere near that type of accuracy with the MobileMapper 60 internal. And even though I post-process that, it's a U-Blocks chip. It's only got L1 code information. It doesn't have carrier phase, doesn't have L2. So that's why I don't get those levels of accuracy when I'm doing just the internal GNSS engine from the MobileMapper 60 as a for instance. And going back to York's question earlier, if I were using my Samsung phone and trying to do this, well, number one, in the Samsung phone, let's look at this middle example. I don't know what's in the Samsung phone. Is it U-Blocks? Another chip, because I only understand U-Blocks. And if there's another chip, I'm not going to be able to collect raw data on my Samsung. And even if it is a U-Blocks chip, what type of U-Blocks chip? Is it compatible? So when we start talking about third-party devices, the actual hardware for the data collection, I would limit my choices to real-time if it were me, because there are too many unknowns about the raw data coming out of a phone or a Nexus or some unknown Android device. Next. So here the main thing is down below. I mean, you can't visibly see a huge difference in the before post-processing and after post-processing graphics, but maybe in the table you can see the estimated precision in the north, south, east, and west on the points before post-processing, both vertically and horizontally, versus what happens after post-processing. So you basically are getting an RTK fixed solution in a post-processed world. And post-processing used to be kind of like the word calculus or trigonometry. It sounded so complex, and yet MobileMapper Office has stripped away this complexity and made it quite simple. So I would not be afraid of it. I would just be careful. When you're post-processing, you get one chance to get the data. So collect more data than you need, long continuous files. Next. I didn't show this to you earlier, but I mentioned it about the internet download capabilities of MobileMapper Office. And here you can see I said search up to 3 stations, right? So it sees my raw data, and when I hit the search button, it's going to go out and find the closest 3 stations. Now, those 3 stations could be 1,000, 2,000, and 3,000 miles away, right? So be careful about this. Sometimes you want to limit your search. Give me some that are within 10 miles of my location. Next. So lots of files coming out, and let's just take a look at the first column where it says nope, go back. The first column here where it says JNS 3D point final, right? Well, if you look down below, the next batch says JNS 3D point post-processed. And then down below that, you see the same shapefile again, JNS 3D point with no parentheses, right? So you've got 3 sets of shapefiles for a 3D point. And the reason for this is that shapefiles are database oriented, that DBF database file. And what DBF implies is that there is no save as command. Every time you make a change, the change is saved. And we wanted you to be able to go back to the original data. And we couldn't if we left it in a straight database format. So what we've done is the last set, the JNS 3D point, are your original shapefiles as they came out of the data collector. Then we post-processed them, and then we deliver the final file. Now there could be some tinkering. Let's say, for instance, let's say you did the post-processing before you moved the base station to its control position. Then you would have a difference between the post-processed and the final set of shapefiles. But typically, final and post-processed are going to be the same, and the deliverable here are your final shapefiles. Next. I think my next slide actually shows that. So these are the original files, as I mentioned earlier. Next. These are the post-processed file. And then you've got your final. These are the deliverables. And here, the vectors passed or vectors failed tells you about the quality. There are some quality settings that you can make. And depending upon how tight you make those settings and how good your data quality is, you can get red lines for vectors that have failed the quality test, or typically green vectors for vector quality passed. Next. You also have this ability to export your work. So this is the same set of point, line, and polygon that we saw earlier. You now know where I live, and you can see that we can export this to KML so that you can visualize your data inside Google Earth in a very user-friendly format. Next. I think that might be it. So, it was a mouthful, and I will turn it back over to Joe Binder to host the question and answer period, but I will be here ready to answer questions that he might ask me to. So, back to you, Mr. Binder. Thank you guys very much.
Thank you, Mr. Sass. Appreciate the detail there. I don't know if I can see the questions on the board here, York.
Yeah, I don't see any additional questions right now. I'm not sure if Mr. Sass mentioned it, but one thing to point out, I guess, if somebody wants to try it out, remind us the limitations if somebody wants to download MobileMapper on their Android device or a Spectra Android device. What things can they do just in the trial mode?
I'm not sure that they can do I don't know that, York. I'm sorry. I
Okay.
should know that, and I will try and research that while we're going on in the background. But
I believe that it is a 30-day trial, if I recall correctly, that they can load it up, and it's a 30-day trial.
Okay, great. Thank you. I think one of the other things to point out is, you know, some clients are having difficulties adjusting to cloud-based solutions. So maybe make a couple of comments about MobileMapper and the fact that it doesn't really have to interact with the cloud, I guess, except for the license install. But after that, it can be completely on the device. Is that correct?
Actually, it doesn't even need to be on the cloud for the install. So that's a proof of purchase number. You'd have to, pardon me, get on the internet to download the program. If that's what you mean by install, then yes. But then the code itself is something that they would manually type in. And from that point, there's no need to be online with the device. They can transfer the hardware or the software via hardware cable or USB drive, whatever their device may support.
I think, though, that what York might be mentioning, you do need to be on the internet for that POPN to get properly registered with the device and the Oracle database. That's a one-time deal, and typically you're at your office on your Wi-Fi network when that happens. But then after that, it's completely standalone, with the exception if you want to save your data automatically to a Google Drive, then obviously you would need connectivity for that. But even so, even if you had it set up to save to Google Drive and you had no internet connection, it's still making a locally saved copy, so no risk.
Great, thank you. And anybody else, you're welcome to unmute yourself and ask a question verbally if you'd like to for either of these two gentlemen, or certainly put it in the chat window, and we're happy to have them answer it that way.
Of course, if any questions do, pardon me?
Hello? Hey, how you doing? This is Marco from Southwood Water Management. I have a quick question. Is there a way to get I kind of tuned in a little bit late. Is there a way to get a copy of the presentation?
So yes. We're recording the presentation, and either tomorrow or on Tuesday, you'll be sent an email with a copy of that. So yes, you can listen to the entire presentation.
Awesome. Thank you. Thank you very much.
I found in the Getting Started guide for MobileMapper Field, if you don't have a POPN, you may install and run the software by clicking on the Start Trial button. The trial mode is only intended for evaluation purposes. In trial mode, you are not allowed to use the export and import functions, and all the jobs you create cannot be reopened in a fully registered MobileMapper Field. On launching MobileMapper Field after the trial period has expired, you will be prompted to register.
Great, thank you. Anybody else care to ask a question either via chat or verbally? Now's a great time to get a hold of these two gentlemen and ask your questions.
If you think of questions afterwards, feel free to reach out to York. He can pass them on, and we'll be happy to get back with you directly as well with any specifics that may come up as you think about this overnight.
Great. Well, I don't see anything else coming through, but Mr. Sass, Mr. Binder, certainly appreciate your time today and kind of informing us better about this particular software. So thank you very much.
Thank you
Thank
all
you.
for your attention. Have a great day.